Hello everyone, welcome back to the channel. Today we are going to analyze the half wave rectifier circuit, both theoretically and practically. If you enjoy electronics and circuit analysis, make sure to subscribe and support the channel. During the positive half cycle, current flows through the diode and reaches the load resistor. As a result, we get a positive half sine wave at the output. During the negative half cycle, the diode blocks the current completely, so there is no output during the negative cycle. Because only one half cycle appears at the output frequency is equal to the input frequency, so the output frequency is still 50 Hz. Now let's analyze the rectifier circuit mathematically. The transformer turns ratio is 9:1. Input voltage is 220 volts RMS at 50 Hz. The primary peak voltage is 311 volts. The DC output voltage of a half-wave rectifier is the output DC voltage is approximately 11 volts. After subtracting the diode voltage drop, 10.3 volts. Load resistance is 1 kilo-ohm. The load current becomes 11 milliamps. Now let's check the 1N4001 diode datasheet. The average forward current rating is 1 ampere. 1 ampere is much higher than 11 milliamps, so the diode is safe in terms of current handling. The peak inverse voltage is equal to the secondary peak voltage. According to the datasheet, the VRRM of the 1N4001 diode is 50 volts. Since 50 volts is greater than 34.5 volts, the diode is also safe in terms of reverse voltage. Both 1N4001 and 1N4007 can be used in this circuit. So far, everything was theoretical. Now let's build the circuit and compare theory with reality. We used a center tap transformer and connected only the outer terminals of the 12012 output. The circuit uses 1N4001 diode, 1 kilo-ohm resistor, and a breadboard. Now we compare the theoretical and practical measurements. Half-wave rectifiers are simple and low cost, but they waste half of the input signal. The output ripple is high and efficiency is relatively low. Because current flows only during one half cycle, transformer utilization is not optimal. Despite these limitations, half-wave rectifiers are still useful for simple, low-power applications. As we can see, the practical values are very close to the theoretical calculations. Thanks for watching this video. I hope you enjoyed the practical and theoretical analysis. If you liked this video, don't forget to like, share, and subscribe to the channel.